Hey there, everyone. Ryan Schul here. Welcome to my data science channel. So in the project today, I want to look at supply chain management and use Python to solve some supply chain challenges or answer some supply chain questions. So supply chain is using time series forecasting, and we're looking at movement of products from point A to point B, or maybe A to B to C to D to E to F, right? It goes all over the place. So we use time series forecasting as a tool to manage operations, supply chain events, what happens first, what happens next. We look at transactional, historical transactions, and try to understand actionable insights to see what happened in the past and understand what is going to happen into the future, right? We try to predict future trends, stockouts, empty shelves, or products are not selling as fast as we would expect, right? So we want to keep the shelves pretty full. If it's selling out, then we need to level up the supply chain, right, and get products out there faster. And if it's not selling so fast, then we can pump the brakes a little bit and slow it down. And maybe we work in a big corporation and we have to talk to marketing or sales or something like that. Why are the products not selling fast enough, right? So overall, it's a very interactive and collaborative place to be, right? We try to improve business planning. We try to reduce stockouts or overstocks, right? Like I was just saying a moment ago, selling too much, we're going to have a stock out, and not selling enough, and we're going to have overstocked and shelves where a lot of product is sitting, but nothing is moving, right? So we try to optimize resource allocation, make everything efficient, the labor, the capital, the materials, the shipping, driving the truck from the warehouse to the point of sales, right? This helps enhance customer satisfaction, right? If the customer walks into the store, they expect the products to be on the shelves. They want to make a purchase, right? If it's overstocked, it's fine for the customer, but it's a little bit bad for the business. If it's sold out, then the customer is going to be disappointed. Maybe they're not going to come back again. Maybe they'll go to another store down the street, right? So it supports cross-industry use cases. Again, time series modeling, retail forecasting, manufacturing, logistics, energy, healthcare, financing, right? It has an impact on the entire business, right? And we can capture different data patterns, understand trends, seasonality, cyclicality, and make important decisions, and gain insights and make intelligent decisions, right, about what's going to happen into the future. So I'll start off by saying I would love to work in the supply chain area. My background is finance. I've been on Wall Street for like 22 years. So if somebody called me with a job offer to go into the supply chain area, I would say absolutely yes. I've never got a call like that, so I never had an opportunity to get into it. And I don't have this data, so I have to create it myself, right? So I put together a script to dynamically create this data. I looked online a little bit. I didn't see a whole lot of good supply chain data, so I just made it myself. So we have products, suppliers, and locations. Okay, and for date and date range, I'm creating a demand, lead time, stock on hand, so on and so forth, location, cost, and shipping delay. And I'm appending everything into a data frame. So this is what we end up with when I run the code: the date, the product, supplier, location, demand, stock on hand, replenishment, lead time, back order, shipping delays, cost per unit, and total cost, which is basically the cost per unit times the demand plus the replenishment, right? So if the demand is 96 and the replenishment is, where is that? Zero over here. Oh wait, replenishment. I don't even see it here. Okay. So anyways, total cost is cost per unit times the I think it's 6 times 96. I think that's what we're getting at. Okay, so that's fine. Demand plus replenishment. Oh yeah, I see it now. So 0 plus 96 is 96 times 6 is 576. So that's how we get that. Okay, so we are going to go ahead and look at a rolling demand here and plot that. So again, I didn't have this data, so I just had to create it. That's what I did above. I'm going to plot this because when I look at this data, okay, it looks good. I have product, supplier, location. But what does this really mean? Like, a picture is worth 1,000 words. I always say that. But I want to see, like, what are these products in terms of demand over time? Is demand increasing? Is it decreasing? It's bouncing around. I can see it's pretty choppy. This is a plotly chart, so I can zoom in and I can zoom out. All right, I like these plotly charts a lot because you can see a lot of the details. So this is the average. This is actually the 30-day average. I actually changed this. This is changes just before I ran this. So let me rerun this just to make this correct here. Okay, so I'm taking a rolling 30 days, right? Minimum period is 1, and this is an average. And I've said this in several of my other videos. In the data science space, we have all kinds of wonderful analytics. There's thousands of things that we can do, right? Like there's so many, it's countless, right? But what do we do 95 to 98% of the time? We use count, we use sum, and we use mean. Even though there's 1,000 different types of analytical processes that we can run, most of the time it's the average, or count, or sum, right? Those are the three things that you use predominantly. So if you know how to count, if you know how to sum, and if you know how to calculate a mean, which is the same thing as average in statistics, they call it mean, it's really an average. If you know how to do that, you can become a data scientist, right? It's not hard to do that. So this is the 30-day smoothed daily demand, right, for the products. So we have the 4K LED television. And I love these plotly charts, how you can click on these different elements and they collapse or they are exposed, right? So here's the product by date, cost, smoothed. This is the demand smoothed, and this is the back order smoothed on the y-axis. Okay, so these are just the transactions over time for the television, for the Bluetooth, and for the smartphone. Okay, so moving on here, we are going to look at different confidence intervals and try to understand the stock out for each one. Okay, so again, we're looking at the mean. See what I told you before, almost 95 to 98% of the time it's a count, it's a sum, or it's a mean. That's an average. We're looking at the mean rolling window for 7 days to understand the demand statistics, the mean demand, that's the average, and the standard demand, okay? And we're going to create confidence intervals based on these three features. So we have the average demand. 0 is just the average. 1.28 is the standard deviation. 1 standard deviation, 1.96 at the 95% confidence interval. If you don't know what that is, I can give you a quick breakdown here. Google confidence intervals. Let me see if this thing comes up. This looks promising. Let me see. Oh, that's not what I want. Oh, maybe this. Yeah, this is close enough. If you look at this right here, it's going to help me out. So 1 confidence interval is 68% of the standard normal distribution curve. 2 standard deviations from the mean is 95%, and 3 is 99.7. So 3 standard deviations from the mean covers 99% of the scenarios that you'll see in the standard normal distribution. So it's 0.3% of the time. It's greater than 3 standard deviations positive or less than 3 standard deviations negative. That's how we get the confidence interval at 95, at 80, and at 50. So 50 is right in between. So 50 is the midpoint. This is 1.28, and this is 1.96. Actually, it didn't really answer the question. I wanted to see the 1.96. Okay, let me see if this will be it. Yeah, kind of does. Okay. So here's the 1.96. 0 is right in between, and 1.65 is 90%. So 1.96 covers 95%, and 1.65 covers 90%. So that's what I'm using that. That's 80%. This could be 1 point. This could be actually 1.65. That's fine. It's fine. I think it's spread out a little bit. If I had 90%, it would be a little bit too close to 95. So I think I'll just leave it like this. So that's how we get these standard deviations from the mean. This is right between, right? This is 80%, and this is 95%, right? So go ahead and run this. Control Enter to run. We have the expected demand. Confidence interval 50%. That is going to be the same thing. 1.04 is a little bit higher. 1.07 is the highest, and the stock remaining is over here. Okay, so the stock remaining is basically the current stock minus the cumulative demand. Okay, so we have that table. And then we have, again, our products. Again, it's a very simplified example here, right? In the real supply chain distribution network, like you would have thousands of products or maybe even hundreds of thousands, right? So it gets pretty complicated. I don't have that data, right? I don't work in the supply chain environment, so I'm just making this up, but I'm trying to make it realistic and show you how this stuff works, right? So we have the products, we have the number of days. We're going to put all the products and days into a data frame, control enter to run, and we're going to look at stock levels and then lead times to deliver. So the delivery time could be, it could be a few hours, it could be a day, it could be a couple of days, right? So we have to take that into consideration. And if stock levels are going down to a certain amount, if we have like 20% remaining, and we know the lead time is 1 to 2 days, we have to enter an order now, right? So we have to have an automated system that tracks this stuff in real time. We get below a certain level. If we have 100 items and we sell 80, it's time to put in an order, right? And get the stock levels back up to 100%, right? So we have to put that order in, especially if it's going to take a couple of days to execute the order. So go ahead and run this. And we get our new data frame down here at the bottom. Okay, so what we're looking at here is now, again, the products, the reorder date based on the stockout levels and how long it takes to replenish the stock. The reorder quantity, right? We have to know how much order and the projected stock at the order, at the point of order, right? And then we have the dates that the order has to be executed, right? So now we're looking at a realistic reorder report that tells us exactly how much to order, the date of the order, the reorder quantity, and the projected stock at order, right? So we know the specific item being tracked, the TVs, the smartphone chargers, there's some Bluetooth thing in there, right? The day that the order must be placed in time to get the order on the shelves, right? Because it takes a little while to execute the order. It could take a couple of hours, maybe, if the warehouse is closed. If it's far away, it could take a couple of days, maybe a week, right? And the longer it takes, the sooner we have to put in that order, right? The recommended order size, that's very important. Are we going to order 10 products, or are we going to order 100, or are we going to order 2,000, right? We have to know that. And then the inventory left on the store shelves, because this is all that's remaining right here, or this, before we run out of the supply, right? And we don't want to have stockouts, right? So let me do one more example here, just to create a chart and to show you the stock forecast by mean demand. So if the demand is 150 products per day, we have the month of January 2025. Now it is mid-June 2025 here when I'm recording this video. But if the mean stock forecast is 150, this shows us when the order has to be in. I can go to 100, right, and replot this. Oh, I think it was at 100. This is 150. As I click this drop-down menu, the chart is replotted. This is 250. And this is 300. And again, this shows us the current stock. This remains stable. The current stock doesn't really change, right? But we could have a plot where the stock is depreciating over time, declining over time, right? That's the stock out. It's showing us fewer and fewer items on the shelf in real time, right? The demand in this case is 300, right? If I go back over here, now the demand is 100, and we have the confidence interval at 80% and at 95%, because we don't know exactly what's going to happen with exact foresight, right? So we have these confidence intervals, so we can be 80% confident, 95% confident. We can be mostly confident. Maybe there's a bad storm that comes into the area, or hurricane, snowstorm, rainstorm, or there's some, who knows what, a big fire or something, right? And the delivery truck can't get through from the warehouse to the delivery point, right? So we don't know exactly like when the truck is going to make the delivery, but we have these confidence intervals, so we know approximately what's going to happen and how long it's going to take. But there's always a probability. You don't know with absolute certainty what's going to happen in the future, but you know approximately what will happen, and you're either 80% certain, 80% confidence interval, or 95% certain. That's the 95% confidence interval. Okay, so that's how it works. So that's it. I just wanted to take you through and show you the ins and outs of supply chain management. As I understand it, I did a lot of research putting all this code together. I don't work in the supply chain space. I wish I did, and I wish someone would call me on the phone and make me an offer. I would jump, I would leap out of my seat and go there tomorrow. But I don't think it's going to happen anytime soon. But I've learned a lot putting this together, and it was a great experience for me. Sharing my knowledge here. I'm going to drop the video soon. Hopefully you guys can learn a thing or two when you go through the code, copy and paste it. I'm going to share all the code with you. I will export this right now, save as HTML, and I will share the code with you so you can copy and paste that and run that in your own environment, okay? And the file is right here. I will post the file and I will post a video in just a bit. Thank you for your time today. I really appreciate that. And I will see you soon when I make the next video. Bye for now.